Okay, so this talk is on stealing ideas from other languages and bringing them home with Perl. Some of you probably already saw this. Before we start, this is my shameless plug for the Salt Lake Perlmongers. This is a newly rebooted group. We had our first meeting last month, and we will be having a meeting again this month, posted at Bluehost in Draper. And see saltlake.pm.org for details after the talk. So, was anybody here at YAPC North America 2012? The conference NA 2012. At that conference, Miyagawa gave a talk on becoming a polyglot, and it kind of brought to my mind some ideas that I've been thinking about before for a while. And so there's a quote from Miyagawa: "In Ruby, there's just a culture of doing crazy things, and I like it." And so this talk is about finding those crazy things, or finding those rock solid things that are being done in other languages. And it's okay to like other languages. It's okay to venture outside of Perl and not feel like you're being a traitor to Perl. It's good for Perl. So it's okay. Take a deep breath. This is a quote from T.S. Eliot. "One of the surest tests of the superiority or inferiority of a poet is the way in which the poet borrows. Immature poets imitate, mature poets steal, bad poets deface what they take, and good poets make it into something better, or at least something different. The good poet welds his theft into a whole of feeling which is unique, utterly different from that from which it is torn. The bad poet throws it into something which has no cohesion. A good poet will usually borrow from other authors, remote in time, or alien in language, or diverse in interest." So T.S. Eliot apparently could have been a programmer, because this is really the gist of what language design has been over the last 40, 50 years, is stealing the good ideas from other languages and bringing them home. We want to look outward toward our neighbors. By looking outward toward the other languages and toward our neighbors and toward the greater programming world, our code becomes better. Perl benefits because we're able to bring those ideas home, and we become better contributors to the global programming world, the global development world. As we bring new ideas into Perl, Perl becomes more relevant, and we're able to bring Perl up into the 21st century and make it a modernized language that is used for getting real things done today, just like it was used for getting things done 10, 15, 20 years ago. Somebody made a comment to me a couple weeks ago, "Oh, you develop in Perl, that's such an old language." But then I started thinking, what does that mean exactly, old language? C is an old language, and yet it's used every day and it's everywhere. C++, the same thing. Even Java, by today's standards, is a fairly old language. It's been around. It was just getting started when I was finishing up at the U, but it's still, that still makes it an old language. To me, though, what really constitutes an old language is a language that's dead, or a language that's not being used anymore. I think that we could probably agree that COBOL is on its way out at this point. That we might consider an old language. But a language as flexible as Perl, I don't believe is on its way out yet. And it's not, I don't think that it's going to be. I think that we're still moving forward. So, okay, sounds great. Where do we start? Bernd Strauss, "Thoughtlessly applying techniques effective in one language to another typically leads to awkward, poorly performing, and hard to maintain code. Such code is also most frustrating to write because every line of code and every compiler error message reminds the programmer that the language used is different from the old language." I'm sure that everybody here knows at least two languages, and computer programming languages. And how many of you, as you've learned that second language, have just been frustrated along the way because it isn't like the first language? And how easy is it for us to, as we venture outside of Perl, to get frustrated and think, "This I can't believe it. Why isn't this more like Perl?" I know I certainly feel that way sometimes when I have to work in, I won't say the language's name, but anyway, that's honestly, that's probably mostly because we're not familiar enough with that other language. And as we become more familiar with it, we're able to start to see what merits it has and what we can bring back and what we can learn from it. So, why does everyone hate language X? Because they thoughtlessly apply techniques effective in one language to another, or because the frustration in every line of code. You can see that. We do this all the time. And we're not the only ones. People in Python, C++, whatever, they do it too. They look at Perl and say that it's frustrating or that it's a mess or that it's read-only. Every language is read-only if you make it that. Every language is frustrating if you're not familiar with it. So it's time to kind of break down those barriers and open up a little bit. Again from Straustra. Every language can be a fertile source of ideas. However, ideas must be transformed into something that fits well with the general structure of the language in order to be effective in the different contexts. So, by having defensiveness, by feeling that my language is superior, that no other language can be as great as Perl, half-hearted efforts at learning other languages, closed-mindedness, all these things are going to stop us in our tracks. Perl will become a dead language if that's the way we think. The winners are, of course, those that are opening, welcoming, outward-looking, respectful of other languages, willing to dig in and take the time to really learn what makes another language tick and what that language can provide to us, what it's good for, and what good ideas that language has that maybe we should have thought of for ourselves. So, a few stolen ideas. Perl did not invent web frameworks, but Perl has some great web frameworks, and Perl learned how to make great web frameworks by seeing what other people have been doing. Catalyst and Modulicious, for example. Miyagawa, in his Polyglot talk, talks about how he stole the ideas for Plaque and PSGI from Python. And yet that's something that we see all over the place in Perl now. Plaque is just a great foundation. There's an old Usenet posting from Randall Schwartz where he showed people how to do a short seam transform. Do you guys know what that is? It's a map transform and map again to a way of can't explain it in 20 seconds. Anyway, the short seam transform is really a Lispism, and Randall Schwartz mentioned that in his first Usenet post where he explained how to use it. Memoize from Mark Jason Dominus is really a tribute to functional languages everywhere, whether it's Lisp or whether it's Haskell. Memoize is not something that Perl invented, but it's something that Perl does really well as an optimization. And even more modern object frameworks like Moose. We didn't invent object-oriented programming. We didn't invent the declarative form of object-oriented programming like Moose has, but we were able to learn it from other programming languages, and we've got a great foundation now because of that. Again, Straustra. We're going to be talking about C++ in a few minutes, which is kind of why there's so many quotes from John. The programming language serves two related purposes. It provides a vehicle for the programmer to specify actions to be executed, and it provides a set of concepts for the programmer to use when thinking about what can be done. If you've ever learned a foreign spoken language, there becomes a point in your learning process where you're no longer thinking in English and then translating into Portuguese, for example. I speak Portuguese. There becomes this point. And the same goes for programming languages. There becomes a point where you're no longer thinking, now let's see, if I were in Perl, I would do it like this, but I'm working in C++, so I need to do this. And so eventually you can get to a point where the programming language becomes a medium of your expression, or becomes even something that helps your thought process to evolve. So enough about general things. Let's talk about C++ a little bit. Any C++ programmers here? You. Any others? It's a good language. It's a pain in the rear at first, and it's still a good language. Multi-paradigm? Still. Yeah, still. It's a multi-paradigm language, statically typed, free form. It's compiled, it's general purpose, it's portable, they say. It applies to many problem domains, procedural, objects and operator overloading. In more recent years, it's acquired generic programming techniques through templates, functional techniques through lambda expressions, which were just introduced in C++ 11. And it can both work in high-level situations or for low-level work. Strauss-Stroop again, my initial aim for C++ was a language where I could write programs that were as elegant as Simula and yet as efficient as C. Again, influenced by a couple of different languages, more than a couple, but at least two mentioned here. So if we look at the history a little bit, C++ was inspired by C, Simula, Smalltalk, a few other languages. I think Algo 68 was another one that Strauss-Stroop mentioned was kind of one of his foundations. It came about in the early 1980s, and it's evolved immensely and continues to do so. C++ 11 was, by introducing just a few concepts, has been kind of a revolutionary change to C++. Perl, inspired by C, Smalltalk, Shell, scripting, sed, awk, evolved in the mid-80s and has evolved immensely and continues to do so. So in this talk, we're not going to really try to focus on idioms too much. If we look at the idioms like the Schwartzian transform, those sorts of things, it's very seldom that you find an idiom that works great in one language and works just as well and isn't clunky in another language. And syntax is even worse if we try to focus on, well, they've got a semicolon here and they don't require brackets here. There's no point. And it just becomes frustrating to look at that sort of thing. What we'd like to focus on is how has the language evolved, because we can learn from the evolution of the language. The cool things that the language provides. What does the language's community provide, or what is the community like? What strategies develop for making easy things easy and hard things possible? Concepts that may be generally useful, and tools developed for and or with the other language. So, if we look first at C++'s evolutionary goals, the primary evolutionary goal has been to make the language easier to use while not making it any less powerful. There's also been a push in C++ 11 to make the language more efficient at runtime. Some of the ways that that's done is through templates, which allow code to literally be executed at compilation point. R-value references, move semantics. Move semantics allow you to copy an object to another object and literally just move the guts. If you know that an object is going to fall out of scope, then with move semantics, you can just move the guts out of that object into a new object and not have to do a full deep copy. The new object just takes over ownership of the old object's contents. That's called move semantics, and it's useful for when a function is returning an object, for example. And it's an optimization that C++ now provides. Constant expressions, relaxed plain old data type definitions, which provide for cheaper object motility. Making it easier to write robust code. And we're going to go into some of these concepts in a little bit deeper depth, but resource acquisition is initialization, RAII. Has anybody heard of that term before? RAII? You know, a while ago. We'll go into it because it's something that has just become a real foundation of using C++ now. And yet it has some application to Perl, even though Perl hadn't given us, I'll explain in a minute. Exception objects, exception specifications, pure virtual functions, which are declared interfaces. In Perl, we might use roles, for example, with moves. Managed or reference counted pointers. C++ now has reference counted pointers, which is similar to Perl's reference counting, lexical scoping. And the rule of three, which we'll talk about in a minute. C++ is also trying to improve the compiling experience by giving better runtime errors, better compile time errors, and also by reducing code bloat through external templates. And then, of course, maintaining high-quality extensions and a roadmap to standards evolution. C++ has there's kind of a way that code can evolve from a community-contributed code to eventually becoming core code. And we see some of that within Perl as well, and we'll talk about that. Languages are getting easier to use, however, it may not seem so because we're trying to achieve far more difficult objectives these days. Isn't that the truth? Just look at Unicode. It used to be great when everything was fit into 127 spots, but we're not in that world anymore. Okay, so let's look at the first thing that C++ is evolving toward is becoming a more easy-to-use language. So what is Perl doing to become a more easy-to-use language? Well, the good news is that we already have a lot of the things that other languages are evolving toward. We already have reference-counted variables. We already have data type abstraction, generic programming, great unit compatibility, especially with more recent versions of Perl, powerful containers, closures, which allow for lambda subs. We've got a lot of that covered. Moose is making the object system more powerful and easier to use. And we have other favorites like list utilities and more utilities that can help us do all kinds of crazy things with lists. And you can see the evolution of making difficult things possible. Early on, if you wanted to do web programming, you'd be working with LWP, and then later you'd be working with CGI. And nowadays you work with Dancer or Modulicious or Catalyst frameworks. So they just take everything to a much higher level of abstraction. And was it said that every problem in computer science can be solved by one more layer of indirection, except the problem of too many layers of indirection. But anyway, Dancer, Catalyst, Modulicious, these are all things that are standing upon the shoulders of giants and have shown how Perl is evolving. Instead of using claimed less references as objects, now we can use Moose, which even now, if you don't need the meta-object protocol, you can use Moo. Instead of trying to pass data back and forth with XML, people have moved on to YAML, and then they've moved on to JSON, which is so much easier to deal with. And so there's an evolutionary process and some of these things are not things that are Perl-centric, like XML to JSON nowadays as being kind of a standard data interchange format. It's something that was invented outside of the Perl community, but we're able to adopt it and bring it into what we do as well. So good ideas come from all around us. Now, what strategies can we use to make Perl more efficient? So we talked for a minute about how is it evolving. What can we do to make it more efficient? Well, if you're using Moose, then make sure that you end with no Moose, that you end with the package make and edit immutable, namespace autoclean, all these sorts of things. Or use Moo and just get rid of the meta object protocol if you don't need it. Use Memoize. Has anybody ever used Memoize? Yeah, okay. It's kind of fun. It's old. Mark Jason Dominus invented it back in, I think, 98 or something like that, probably before that. But it's a tool that allows you it basically handles caching of functions, essentially. If a pure function receives the same input 2 times, then it doesn't have to calculate its output the second time. It's cached its output. Time Memoize is part of the Perl core. I didn't even realize it until I started digging into the core a little bit more. It's a core module that allows for lazy loading of hash elements.
You know when it became core?
No, I don't. I didn't look at that. That's a good question. It kind of took me by surprise, so I probably ought to investigate it. Benefit from constant folding wherever possible. The easiest way to benefit from constant folding is to use constant, which is contrary to what Damian Conway puts into Perl best practices. But when you, quote, use constant, then Perl is able to optimize away the function call. And so that's a runtime efficiency. Lazy building. In Python, they use generators, right? List generators, which can be used to generate lists lazily, so that you don't have to create an entire list up front. You can generate the next element of the list as you need it, right? Mark Jason Dominus talks about this in his book, Higher Order Perl. In Perl, you would probably use a closure. You'd wrap a function in a closure and allow it to produce its next element each time you call the function. But also, on CPAN, there's a couple of great modules, listgen and listgen-lazy, which are used which can be used for list generation, lazy list generation, and they give us a lot of what is built into Python right now that people think is one of the great reasons to use Python. We've got it in Perl. Use auto-use. Auto-use will load this is also part of the Perl core. And again, I don't know when it became part of the Perl core, but it will allow you to load a module at runtime when the first function is called from that module that needs the module. So if the module exports food, then the first time you call foo, then the module will get loaded. And if you don't ever call foo, then the module will never get loaded. So it's a startup efficiency with a small runtime penalty, I suppose you would say. But the runtime penalty only comes when you first use it, the first time you use the function that module provides. And I say with caution because on the one hand, this provides some form of efficiency. On the other hand, it can provide an action at a distance. You can have a bug turn up that only turns up when that function is first called. If you read the documentation for auto use, it suggests commenting out auto use in development, and then when you're ready to go to real testing before production, then go ahead and put it back in again. And we can look at low-hanging fruit as well. Stop copying everything. We don't have to pass an entire list around. You can pass a reference to a list. And sometimes that makes the code not as clear to read, and so you have to weigh legibility versus efficiency. But in C++, one of the big deals now is to use references or use move semantics, so you don't actually have to copy an entire object. Is this all legible? And of course, even within Perl, when you run out of when it becomes time to trim cycles, you can always drop into inline C or inline C++ or even pure XS, which is a quagmire to get into, but it can be kind of fun sometimes. One of the design goals of more recent versions of C++ has been facilitating more robust coding practices. And so what can we do in Perl to take on that type of a strategy? Well, better exception catching, try tiny versus using a val with its issues. Exception class allows you to throw an exception class rather than just an exception string. One of the complaints that I hear about Perl is, when you throw an exception, you're just throwing a string, and then somebody's got to use a regex and decipher what that string was so that you know what the exception was. Well, you can throw exception classes, which C++ also can do, and many other languages can also do. And that exception class can have its own handlers built in as well. Use autodie, or never forget to check the return value of system calls. Use carp so that you get better reporting on where your errors are coming from. Use moose and moosex types. Moosex types allows you better ability to kind of catch errors early on in passing an array ref rather than passing a list, that sort of thing. Params validate. Smart params really helps when you're creating functions that have a lot of parameter lists. Now we're going to talk again about resource acquisition as initialization, and the rule of three. So first, resource acquisition is initialization is a terrible way of saying that when you construct an object or allocate a resource, do so completely or not at all. Never leave an object in an inconsistent state. It also is a terrible way of saying that when you own a resource, you need to ensure that that resource gets cleaned up no matter what happens. Now, in Perl, we get really accustomed to not thinking about this too much, because when you create an array and then it falls out of scope, the array disappears, right? When you open an input file handle and it falls out of scope, the file gets closed automatically. You don't have to worry about it too much. But there are problems that we don't always think about. Don't forget to weaken or break circular references. If you create, for example, a doubly linked list where each element points both forward and backward, then you now have a self-referential object, which will not fall out of scope unless you weaken or break the reference, right? And don't weaken or break the reference just as a closed function. Break it in the object's destructor, because destructors always get called even when you throw exceptions. When you throw a die or a carp, you'll still go through your destructor. Choose I/O solutions that make it impossible to not close the handle at the appropriate time. So, FinalTemp is a good example of this. The FinalTemp module, you can create a temp file object, and when that object falls out of scope, the temp file will be closed and cleaned up and removed from the system automatically. And that will happen even if an exception is thrown, because the cleanup code is in the object's destructor. An easy mistake to make is to have logic or exceptions that skip past the close of an output object, and you might think, or an output stream. And you might think, well, that's not a big deal because it'll get closed when the program ends, right? But what if you've got a long-running process, and then at the very end, when you finally take it down, a web process, for example, you finally take it down, and you realize, oh crap, this file that we've been writing to for weeks won't close because of some problem that happened. Now, and because you've skipped past the exception that closed it, you now have lost data. So make sure that you're putting your. I like to sometimes put my file handling within an object actually, so that as I open the file in the constructor, I close the file in the destructor, and I make sure that way that the file never doesn't get closed. Managed connection pools with DBIX connector. Another great form of resource acquisition is initialization. You're allowing DBIX connector to manage your database connection. You don't have to think about when to close the connection, when to open it. You don't have to think about what is the Monday morning bug, where you come back on Monday and find out that MySQL has closed your database connection, right? DBIX connector deals with that for you automatically. It won't leave your connection in an inconsistent state. It'll open up a new connection automatically for you. So, resource acquisition is initialization in Perl. Pay attention to object creation and destruction so as to prevent leaks. Never leave an inconsistent state. This is something that's a little bit more of a problem now that we use Moose, because Moose allows us to easily do lazy building, right? So we need to make sure that, okay, go ahead and use that optimization technique, but don't use it in such a way that you can end up throwing an exception in the middle of, or that you can end up leaving your object partially built at a time when you're expecting it to be fully built. Never fail to clean up if normal reference counting and lexical scoping is inadequate. Okay, now for exception specifications. Perl doesn't have them. For the most part, C++ has deprecated exception specifications also, except for one called, quote, no throw. You can write a function in Perl, and you can declare, or in C++, and you can declare that that function cannot throw an exception, or will not throw an exception. And that is a code to that is a clue to the compiler that it can optimize, but it's also a clue to future developers that they don't need to waste time digging into the source code to determine if they have to try and catch exceptions with this function that's being called. Perl doesn't have that, so we need to be extra careful when we're using modules from CPAN or even from the core, that we are aware whether or not that function that we're calling or that constructor that we're calling is capable of throwing an exception. And if it is, make sure that we're handling it gracefully. We have no guarantees, so the code has to be treated with care. So strategies for exception safety in Perl really have to come down to diving into the source code of the modules that we're using, and also really good testing, unit testing. Thank heavens we've got a great test framework system that isn't as easy to use in other languages as it is in Perl. So exception safety in Perl: test. Dive into the source on the modules we use. Don't assume anything, and do practice resource acquisition as initialization, because then you know that the only place that an exception can be thrown is in the constructor if an object fails to be fully instantiated. In C++, you have something called the rule of three. And the rule of three states that if you have an object that requires a destructor to, for example, break a circular reference or to clean up a resource, to free a resource, then that object also probably needs a copy constructor so that you can copy the object deeply, and also probably needs a assignment operator. We don't do much with operator overloading usually in Perl, so we don't really have a rule of three. But we do need to think about it sometimes. What should happen when we copy an object? Should an object be copyable, or should an object be explicitly a singleton object? It's something that needs to be thought about, and it's something that we learned from C++. They spent a lot of time thinking about thinking about the quote rule of three. If I have an object that requires deep copying, if the object were to be copied, then I need to make sure that code is there. Perl is the same thing. If we have an object that we're going to pass not just by reference, but that we need to literally make a copy of, then make sure that we're handling a deep copy. And also, we probably need to be looking at the destructor as well. Okay. Improving compilation and error handling. Use autodie, we talked about that before. Use fatals for warnings. Use diagnostics if you're having trouble tracking something down. Use Moose's type system. Consider prove a compile step. We don't have really a compile step in Perl, but we do have the ability to just type prove. And if you've got your unit tests and your regression tests and your integration tests set up, then you'll be able to catch your errors that might have been caught otherwise. Use test exception so that you can test to make sure that your code is not throwing exceptions, and use test no warnings. Use double cover to make sure that your tests are covering all of your code. And use Movie because it gives you a faster startup time than Moose. Now, next we'll talk about kind of making easy things easier. C++ has developed over the last, say, 8 to 10 years what they call the standard template library, which is really a misnomer because it's not a template library anymore. But anyway, it's what the standard template library is it's kind of the core library. Like we have our core modules that come with Perl. In C++, all of the core library, which provides vectors, a type of array, provides hashes nowadays called unordered lists, unordered maps. It provides binary trees, which are called maps. It provides sets. All of these things are provided with a common user interface. It's a completely different user interface than if you use list binary search. And so we have to kind of learn our user interfaces each time but in C++, every one of those container classes, they call them, uses a common user interface. There are sequence containers called decks, forward lists, queues, priority queues, stacks, vectors, bit sets. There's associative arrays, which are maps, multi-maps, multi-sets, unordered maps, which are similar to a hash. All these containers are now part of the C++ core. And we have access to all of those things. Some of them built right into Perl, like hashes and arrays, which can be used so versatilely. And a lot of them are also available on CPAN. The Perl community's answer, of course, arrays and hashes are like vectors and unordered maps. We have set bag, set scalar, set object, tree binary, tree, tie hash, multi-value. We've got all these. We have many, many more container classes available to us in Perl than we do in C++. But the one thing we have to give up is the uniformity in its user interface. Every time you pull out set scalar, you've got to also pull out the pod and read it again. So that's a difference that maybe we can improve on a little bit, trying to become a little bit more uniform in our approach. The standard template library also provides algorithms such as non-modifying and modifying sequence operations, sorting, binary search, merging and partitioning, heap manipulation, min-max, partial sorting, even pluggable pseudo-random number generators with pluggable distributions. You can generate numbers, random numbers along a bell curve, for example, with the new template library. What Perl algorithms do we have? Well, we have CPAN, and CPAN is our killer app, and so we need to really make good use of it. Some favorites, of course, list utilities, list more utilities, list gen lazy I talked about. Unicode collate is really what we should be using for sort nowadays, as opposed to the built-in sort. If you're still sorting ascibetically, then you're probably sorting incorrectly. Unicode collate is the best way to sort nowadays for strings. And a new one that I learned just the other day, sort key top. This one's great. In C++, you have something called standard partial sort. In Perl, we have sort key top. A partial sort rearranges the elements in such a way that the elements before a predetermined point are the smallest elements in the entire range and are sorted in ascending order or descending, while the remaining elements are left without any specific order. So, the question, how can one find the top 3 values in a list, or say the top 5 or the top 10? The Perl answer would either be to scan through the list a few times and build a list of possibilities, or it would be to sort the list, which is a big O n log n operation, and then pull the top 3 off of the sorted list. Sort key top only sorts the part of the list that it needs, and it actually becomes a linear algorithm. It's an ON operation. So if you only need the first 10 items in priority out of a list, then use sort key top. It's pretty cool. And that's something that really I learned about that because I was investigating, well, how would you do, C++ has this partial sort, how would I do that in Perl? And I was able to find this, and it works great. It's programmed in XS. The next thing to kind of look at is how does C++ acquire its core extensions, and what are the peripheral extensions to the language? C++ has the core language, the standard library, and then beyond that is the TR, the technical recommendations. These are the things that will probably get incorporated into the next version of C++. And then beyond that is something called Boost, which is a third-party library that is a community-driven library that has a very high standard as to what is allowed to get into it. And many things that first get into Boost later get picked up by the technical recommendations and then get picked up by the standards committee and pulled into the C++ core. So that's kind of the evolutionary process. Perl doesn't really have a Boost. We have all of CPAN. And so that becomes, Boost, we can talk about that for a second, is a third-party community-driven library. One installs to rule them all. You install all of Boost all at once. The mission statement is to develop and collect high-quality libraries that complement the C++ standard. Boost only accepts libraries that solve existing problems, exhibit a convincing design, and are developed using modern C++ and are documented in an understandable way. They undergo a review process. There's a Boost committee, and the best of Boost is sometimes incorporated directly into the standard within a few years. So in Perl, we have all of CPAN, which is really kind of hard to get to wrap yourself around unless you've been in the Perl community for a while. And even then, it's still hard. There's tens of thousands of modules on CPAN. And so I guess the question comes up, okay, we don't have a Boost. Do we need Boost? I don't know the answer to this, but it's something that we ought to probably be asking ourselves. Do we need a process by which modules that are just great in CPAN eventually can work their way into the core? On the other hand, I know that the core development of Perl is constantly trying to pull out the cruft and take it out of the core, push it back out to CPAN. So where is that line? Where is that balance? And would something like Boost be helpful to Perl? We don't worry about vendor support, but Perl 6 will, because Perl 6's standard will be Perl 6 will be whatever compilers can run Perl 6, right? Whereas Perl, there's one Perl that you download. With Perl 6, there can be any implementation that passes the test suite. Our current annual release cycle for Perl promotes rapid evolution, more rapid evolution than the standards committee for C++. But with a less well-defined means of inclusion in the core. If we had something like Boost, what would it contain? Moose and Move, template toolkit, Catalyst, Modulicious. We ought to be thinking to ourselves, what are those great modules? You're starting to see some of that happening on CPAN already under the task namespace. Task be like me, task this, task that. People are putting together distributions that pull in a bunch of what they consider the great modules, and then they're putting that distribution up on CPAN. And so that can be one way to kind of investigate what people consider to be the fantastic modules. If we had something more like Boost, who would participate in it? The module authors, would there be a mailing list? Would there be reviewers? Would there be a committee? Would Perl even benefit from something like that? I'm only asking because it's something that's interesting, but I don't know the answer. Other concepts and other lessons or pitfalls that we can learn about. We could be using stricter encapsulation. We can do that with Moose. We should be looking at resource acquisition as initialization to manage our resources and to make sure our objects are always in a consistent state. We should be looking at the rule of 3 and seeing if our objects are being copied, if we're handling that correctly or efficiently. We should always be trying to avoid the slippery slope of operator overloading, which is something that's prevalent in C++ and thankfully not so much in Perl. Look at interface design. C++ has virtual classes which enforce an interface on anything that inherits from them. In Perl, you would use moose role requires, and we should be looking at doing more of that so that our objects have a more consistent interface. So, to sum it up, your challenge Monday is as you find yourself looking at a screen full of something other than Perl, think to yourselves, wouldn't it be great if Perl had this particular thing that I'm working on right now? Or this tool that I'm using? Or how does this concept that I'm working with apply to Perl? Can we bring this back to Perl? And then, of course, because I'm running the Perl Mongers group, bring it back to Perl Mongers and give a talk on it. And this is my shameless plug again for Solving Perl Mongers. Copy down that URL, go visit it, sign up for our mailing list. And our next meeting will be on the 14th, posted at Bluehost in Draper. So that's everything I have.